Okay, in this video we're going to do a little bit of algebra review before we get into some of the stuff that we're going to need for the material that we're going to look at this week. So here we have a function and a few different kinds of things it asks us to find for this function. So most of you are probably pretty good at this first one. It's just asking you to plug in 2. So you're just going to plug in 2 for x. And then you find the output when the input is 2. So you just have to be a little careful about order of operations. Make sure you do the powers before you do the multiplication and division. Alright, so it looks like we get 12 minus 2 plus 1. So that's 10 plus 1, so 11. Okay, so these other ones though, we've got some other symbols in here, so we have to be a little bit careful about that. But we still just want to take whatever's here in the input for the function, and we're going to put that into the function in place of x. So for this one, we'll have 3 times the quantity 2 plus h, that whole thing squared, and then minus the quantity 2 plus h plus 1. So one important thing here is just to notice that what I did with the 2 in the previous problem is the same exact thing I did with the 2 plus h in this problem. Okay, so from here we're supposed to simplify it, so we have to go ahead and do the same kind of order of operations thing that we did before. I should do the exponent first. So I'm going to be careful. 2 plus h, the quantity squared, you don't just square each term there. You have to think about what that actually means. It means 2 plus h times itself, and you're going to want to FOIL that out. And then you've got some things to distribute through here. So let's see, if I FOIL this out, I'll have 4, and then I'll have a plus 2h and another plus 2h. So that'll make plus 4h, and then plus h squared. And then I have to be careful with my minus sign here. Okay, then I can go ahead and distribute through. When I distribute the 3 through the first parentheses, I'll have 12 plus 12h plus 3h squared. And then distributing through the minus sign on the second parentheses, I'll have minus 2 minus h, and then a plus 1. So then I want to just make sure I identify like terms, maybe put this in descending order of degree. So the highest power term is 3h squared. That's the only squared term. I have a couple of terms here, 12h and a minus h, that I can go ahead and combine. So that makes plus 11h. And then it looks like I have 3 constant terms here, 12 minus 2 plus 1. So I'll get plus 11. So there's the simplified version. Okay, so this next one, f of c, I've just got c to put into the function for the input. So I'll have 3 times c squared minus c plus 1. And really, as far as simplifying, it's just a matter of removing those parentheses. There's not much else I can do on that one. Okay, so this next one is pretty similar to the f of 2 plus h. It's just that I have 2 letters here, c and h, instead of 2 and h, but I'm going to start the same way. 3 times the quantity c plus h squared minus the quantity c plus h plus 1. And I'm going to go ahead and multiply out that c plus h times itself minus the quantity c plus h plus 1. So when I FOIL c plus h times c plus h, I'll have c squared, and then I'll have a plus ch term and another plus ch term, so that'll be plus 2ch, and then plus h squared. Okay, and then I'm going to go ahead and distribute through the 3 on the first parentheses, so 3c squared plus 6ch plus 3h squared minus c minus h plus 1. And then don't really have any like terms here to combine, so pretty much I think we're done right there. There's not really any other simplifying I can do on that one. Okay, so we're going to continue using the same function here. We've got f of x equals 3x squared minus x plus 1. And we're going to continue doing the same kinds of simplification here, just kind of increasingly more complicated sorts of simplification. All right, so the first thing that I want to do here, I've got f of c plus h, which I actually did in the previous step, but I'm going to go ahead and write out what that would mean. So that means I'm going to put c plus h into the original function in place of x. All right, so all of that is f of c plus h. And then I want to do minus, and now I need to do f of c. So that's going to be the original function with c plugged in. I do need to be careful here to make sure that I subtract that whole expression though. So I'm going to either put parentheses or brackets there, and I'm going to have to be careful and multiply through by a -1. So remember when we evaluated f of c before, really all we did was replace the x with the c, and there wasn't really any simplifying I could do, so it's just a matter of kind of writing it like that. So I will have to be careful to distribute through my minus sign on that last one though. Okay, and then remembering that c plus h, the quantity squared, means c plus h times itself, so you have to FOIL that out. So I'm just going to write what we got when we did that. And I'm going to wait and distribute through my minus sign on this next part here. I could go ahead and do that or just wait till the next step. I'm just going to do all my distributing at once. 3c squared plus 6ch plus 3h squared minus c minus h plus 1. And then when I distribute through my minus sign on this last one, that's going to change the signs on all of these terms that are inside there. Okay, so one thing that we might notice is that I have a couple of terms that look like they're going to cancel. I have a 3c squared and a minus 3c squared, so those add up to 0. I also have a minus c and a plus c that will add up to 0. And let's see, one more pair of terms here, a 1 and a minus 1 that add up to 0. So when I think about all those terms that add up to 0 and look at what I have left, I want to make sure I don't miss any terms here. I'm going to put the h squared term first, 3h squared plus 6ch, and it looks like I have a minus h term in there also. I want to be careful not to lose that. Okay, so one more here, kind of just a slightly more complicated version of what we did before. So we're going to start the same way. I'm going to put c plus h into the original function in place of x. And then minus the original function with c put in place of x. And then I have the whole thing over h. One mistake that sometimes students make with this is that they'll leave off pieces and they think they're going to come back later and remember to put those pieces back on, but a lot of times they forget. Okay, so I'm just going to be careful with my simplification here and make sure I do things in the right order. So I'm going to do the exponent first. First of all, FOIL out the c plus h, the quantity squared. So we already talked about what that means. And even though I'm not really doing anything with that denominator of h, I'm going to write it there so that it doesn't go away. I'm going to distribute through coefficients on the numerator. Right, and I have a minus sign to distribute through. Okay, and so there's some canceling that can happen here. I need to be careful that I do this in the right order. I have a couple of terms on the numerator that add up to 0. In order to cancel anything with that h on the denominator, I would have to have h being a common factor of the numerator. And as it stands right now, I don't really have h being a common factor on the numerator. But let's look at what happens. Okay, after I crossed out all the kind of matching terms that add up to 0, I have 6ch plus 3h squared minus h all over h. Okay, so now after I canceled like terms on the numerator, we can see that I do have h as a common factor on the numerator. So if I factor out that h, I have to be careful with that last term. I'm left with a minus 1 on that last term. Now I have an h that's a common factor on the numerator, and also that's all I have on the denominator, so I can cancel that out, and I get this expression here. All right, when we did limits, we made a big deal about the fact that this expression, at the instant I crossed out those h's on the denominator, really has a different domain if you think of h as being something with an input than the original one. So this equals right here is actually true only when h is not 0. They are the same when h is not 0, but one of them, the one that we had right before that had denominator of h cannot be 0. This one does allow h to be 0. Okay, so we're going to basically do the same thing here, but just with a different function. All right, so the first one we're just going to put in 2, so 3/5. You could write that as a decimal, but really what we're after here is some simplifying when we've got letters in there. So, okay, when I do this next one, I'm going to put 2 plus h in for the input. And on the denominator, I can distribute through a 2. And then I have a couple of like terms on the denominator I can combine. And that would be simplified form for that. All right, f of c, I'm really just replacing the variable x with c, so there's not going to be any simplifying to do. It's just a matter of rewriting that with c instead of with x. All right, f of c plus h, I'm going to put that whole c plus h in place of x, and then to simplify, really all I can do is distribute through the 2 on the first 2 terms on the denominator. I don't have any like terms, so that's as simple as we can get. Okay, for this next one I'm going to scroll up, so we're going to remember what the function is here, and we're going to put in c plus h and c, and then subtract those two things. Okay, so here we go. We're going to have f of c plus h, so that's what we did just above. We're putting in c plus h in place of x, and then minus f of c. So remember, f of c was the original function just with c in place of x. Okay, so on this first fraction, I can distribute through the 2. All right, then if I want to combine things here, I'm combining fractions, so I actually need a common denominator to combine those fractions. So when I look at the denominators here, I need to think about this in terms of factors. And really, I've got one factor of 2c plus 2h plus 1 as one whole factor, and then another factor of 2c plus 1 as a separate factor on the denominator. So the common denominator is really just going to be the product of those two. So I need to rewrite both of these fractions with the correct common denominator. Okay, so this first fraction, I'm going to have to multiply by a 2c plus 1 on numerator and denominator. The 2c plus 1 on the denominator to get the right common denominator, and then 2c plus 1 on the numerator to balance what I'm doing here so that I'm really multiplying by a form of 1. All right, and then on the second fraction, I'm going to need to multiply by a factor of 2c plus 2h plus 1 on the denominator to get the right common denominator, and so then I will need to multiply by that same factor on the numerator. Okay, I now have a common denominator, so I can combine that into one fraction with that denominator. And I'm going to also go ahead and do a little simplifying on the numerators here. So on this first fraction, I've got a 3 that I can distribute through, and I'll get a 6c plus 3. On the second fraction, I'm going to be careful here and change this to plus a negative 3 so that I don't forget that I'm distributing through a minus sign as well. And then I'm going to get minus 6c minus 6h minus 3. Looks like we have a couple of terms that will cancel on the numerator, a 6c and a minus 6c, and a 3 and a minus 3. So looks like I'm left with, squeeze it in over here, negative 6h over that common denominator, 2c plus 2h plus 1 times 2c plus 1. About out of room there. Okay, so one more of these to do, and we're going to do the same thing with a slightly different version here. So we're going to start with f of c plus h, so that will be 3 over 2 times c plus h plus 1. minus f of c, so 3 over 2c plus 1, and then I have the whole thing all over h. All right, so this is called a complex fraction, when you have a fraction within a fraction, and generally we don't want to leave things like that. We want to simplify that as much as we can. So there are a couple of ways to do that. One way that I would probably prefer to do that is to rewrite this as 1 over h times, and then what I have on the numerator. All right, so then that maybe makes the algebra a little bit easier to simplify here. There's certainly more than one way to do this. I need to get a common denominator here, just like we did before. So my first fraction already has a denominator of 2c plus 2h plus 1, and so I'm going to multiply on numerator and denominator. So I'm going to multiply on numerator and denominator by that 2c plus 1 factor that I need. And then on the second fraction, I already have a 2c plus 1 factor on the denominator, but I'm going to need to multiply by the 2c plus 2h plus 1 factor. So that's what I multiplied by on the numerator and denominator to get the right common denominator. Okay, this 1 over h that's out front, I'm not going to get rid of that yet, but we're going to go ahead now and combine this into one fraction since I have the right common denominator here. Both fractions have the same denominator. So this first fraction, when I distribute through the 3, I'll get 6c plus 3. On that second fraction again, I'm going to distribute through a negative 3. So I'll have plus negative 6c minus 6h minus 3. Okay, I have some like terms on the numerator here that I can add up to 0. So here I have 1 over h times, and then I'm left with negative 6h over 2c plus 2h plus 1 times 2c plus 1. All right, so one last step on this one here. I'm multiplying two fractions, and so when you multiply two fractions, just like if you do it with numbers, when you have something like 1/2 times 4/7, you can go ahead and multiply straight across, or you can notice that if you have a common factor, you can cross cancel before you multiply, and so then you can multiply straight across. So when I was doing this with numbers over here, I noticed that I had a common factor of 2 that I canceled from the denominator and numerator. All right, so on the problem we're actually looking at here, I have a common factor of h on the numerator and denominator that I can cross cancel. And then when I go ahead and multiply straight across here, I have negative 6 over 2c plus 2h plus 1 times 2c plus 1. All right, lots of fun algebra, and we're going to use that lots with the stuff we're going to be doing next.